So question number 8. We're given a relation R on the set R of real numbers, and the relation is given by this. We want to check whether it's transitive or not, and we have to justify our answer. Okay, so is it transitive? So let's take a look at the relation. So we have R equals EB belonging to the set of real numbers, and 1 plus EB greater than or equal to 0. This means that if EB belongs to R, then we must have 1 plus EB greater than or equal to 0. Okay, so these conditions must go together. Now, can we find something to disprove? Can we find a counterexample to disprove transitivity? So can you find what values for A, B and C will you take so that we have 1 plus AB greater than or equal to 0, we have 1 plus BC greater than or equal to 0, but we don't have 1 plus AC greater than or equal to 0. We don't have this. If we can get such values of A, B and C, then the condition is broken and it's not transitive. What values do you think you can use here? Okay, so maybe some of these values need to be negative. Okay, so maybe A, let's take A to be minus 2, let's take B to be minus 1, take C to be minus 3. So minus 2 A, 1 plus AB. So there's 1 plus AB, this gives me 1 plus 2, so this will be 3. Obviously it will be greater than or equal to 0. So this belongs. That means we have AB belong to R. Then do we have BC belong to R? So 1 plus B is minus 1, C is minus 3. So 1 plus this is 3 plus 3 greater than or equal to 0, this is 4. So we do have BC also belonging to R. Now do we have AC belong to R? So 1 plus A is minus 2, C is minus 3, and this is 1 plus 2, 3, 6. So this also, AC belongs to R. But we cannot yet say that R is transitive, because what if it fails for some values of A, B and C? Okay, so we have to try more values until either we get an example that fails, or if we think that we cannot get it, then we try to prove that this is transitive by using a general way of proving it. Okay, so doesn't work with minus 2, minus 1, minus 3. Let's take other examples. So I think you want to get this. I want somehow to get 1 plus AC for this value here to be negative, so that when it adds with 1, it will become less than 0. Okay, so I have to make sure that AC will be negative. So if AC has to be negative, so either one of A or C has to be negative and the other must be positive. So either A will be positive, C negative, or either A will be negative and C is positive. So let's see. Let's just take the first case. What if A is positive? Let's take A to be 2, and C, shall we take minus 3? Let's take minus 2, and B. So what do we take for B? Let's just try 1, right? Then see what we get. So what of 1 plus AB? So 1 plus A is 2, B is 1. So I get here 3, and this is greater than 0. So AB belongs to R. Then what about 1 plus BC? So 1 plus B is 1, C is minus 2. Okay, so now we don't get, I get 1 here minus 2. This is actually less than 0. So this doesn't work. So somehow, I do need to take C to be negative, but then 1 plus BC, it has to be either greater than or equal to 0. So since if it is minus 2, then the second term here will be negative and be more, so it'll be more than 1 here. So I get something less than 0. So to overcome this, I take C to be minus 1. Okay, now see what I get here. So 1 plus BC, 1 plus B is 1, C is minus 1, and I get here 1 minus 1, and that's 0. See, it is still greater than or equal, because we have the greater than. So this BC is in R. Okay, now so having these two in R, now we check for AC. Does AC belong to R or not? If not, then we can say that now that this relation is not transitive. Okay, so what's the value of 1 plus AC? So 1 plus A is 2 and C is minus 1. See, so 1 minus 2, now this is minus 1, and this is not greater than or equal to 0, so it's actually less than 0. So this disproves. So that means AC here does not belong to R, even though AB and BC belong to R. So this works as a counterexample to disprove transitivity. So we write the answer in this way. So we write the answer for A equals 2, B equals 1, C equals minus 1. We AB belongs to R as 1 plus AB equals 1 plus 2 times 1 equals 3. It is greater than or equal to 0. And also BC belongs to R as 1 plus BC equals 1 plus B is 1, C is minus 1, so this is 0, and it is still greater than or equal to 0, but AC does not belong to R as 1 plus AC equals 1 plus 2 and minus 1. This gives me minus 1, and this is not greater than or equal to 0. So hence we can write here, therefore R is not transitive. This is our proof.